So today let's talk about completing the square. Now, when we can't solve a quadratic by factoring, this often means that our solutions aren't rational numbers, so they're radicals. Or even they could be imaginary values. So an alternative method to solving for our zeros is to complete the square. Now, let's just do a couple examples here and see if some of this makes sense. Now, when we say complete the square, what we're going to do is we're going to try and create a perfect square trinomial. So complete the perfect square trinomial. And so what we're going to do first is, if you have a quadratic that has a constant right here, we're going to move that to the other side. So that'll be the first thing. So I'll rewrite this, x squared plus 6x. If I add 16 to the other side, you get that. And so now what I'm going to do is I'm going to add in a value right here, because we want this right here to be a perfect square trinomial. And so how do you do that? Well, you're going to take this number right here, divide it by 2, and square it. So if I take 6 divided by 2 and square it, I end up getting 9. Okay, now you can't just add a value to one side of the equation and not the other, because then the equation's not balanced. So we're going to add this 9 right here, but we're also going to add it over here. So now my equation stays balanced. Now why do I do that? Well, because now I can factor. So this trinomial that I just created is a perfect square trinomial. So that means I could factor x plus 3 times x plus 3. Over here I can just write it as 25. And so if I did this correct, this perfect square trinomial will factor to two factors that are identical. So that means I could rewrite it like this: x plus 3 quantity squared. Well, how do we solve that? Well, what I'm going to do is I'm going to square root both sides. And so when I square root both sides, now the square root of something squared is the absolute value of whatever's being square rooted. But what we're going to do is we're going to rewrite this as x plus 3, and then an easy way to kind of get through all that is we're going to write over here the square root of 25 is plus or minus 5. Okay, again, there's a little bit of, we're skipping over something right there. There's kind of a side step here. When you do this, this actually equals the absolute value of x plus 3. And then when we look to solve absolute value, remember you have to solve for plus or minus. And so that's kind of where this plus or minus part comes in. So I need to solve. So I'm going to get x plus 3 equals 5, and then x plus 3 equals negative 5. And so if I solve, I get x is equal to 2, and x is equal to negative 8. And there you go. I went through and I solved this quadratic by completing the square. Now, I realize that that's one right there where we could have solved it by factoring, but I wanted to give you an example that was, not terribly difficult, just to kind of get the idea. So let's actually look at one where solving by quadratic formula is actually the only, or probably not quadratic formula, the completing the square is one of the only ways you can solve it. So let's take a look at this one. Again, you notice we have this constant value here, so I'm going to move it to the other side. So I'm going to get 4x squared minus 5x equals 12. Now, problem with this one right now is that we have this lead coefficient right here. Okay, and if you're going to do completing the square, you can't have a lead coefficient. So what we're going to do is we're going to divide everything up by 4. Get rid of it. So I'm left with x squared minus 5/4 x equals 3. And so what am I going to add in right here and over here? I'm going to take this term right here, divide it by 2, and square it. And if I do that, 5/4 divided by 2 is 5/8. And if I square it, I get 25/64. 25/64. That might not seem like the greatest number in the world, but no big deal. We can deal with that. And so now I'm going to factor. And when I factor, I get x minus 5/8 and x minus 5/8. Over here, a little more challenging. Well, for now, we can just write it as 3 and 25 over 64. But we're going to change that to a mixed number in a moment. Next step, let's go through and rewrite this. So it says x minus 5/8 squared equals, let's see, if we do 3 and 25 64ths, let's see, what is that? 64 times 3, sorry, I'm doing this on my calculator that you can't see. So I get 217 over 64. So next step, let's square root. And again, remember that's the absolute value, so that's why when I solve this, I get x minus 5/8 equals plus or minus. Now the square root of 217, I don't think there is one, so we're going to leave it as that. And there is a square root of 64, which is 8. Okay, so we're almost done. We'll just slide over just a little bit. Okay, so if we kind of just move things up over here, if I add my 5/8, I end up getting x is equal to 5/8 plus or minus root 217 over 8. And now you can combine those if you really wanted to, if you wanted to put it all as one big fraction. That's fine, but unnecessary right there. So I would actually be perfectly fine with either one of those type of answers. Okay, but again, the steps aren't any different than what we did with the easier one just a minute ago. The only thing different being that you can't have that lead coefficient over here, so you had to get rid of it. Okay, it always has to say x squared in order for you to complete the square. All right, so let's try another one. Let's try one last one here. Again, this would be a good one that if you just hit pause and tried this on your own, it'd be a good step for you. So what I would do, again, as with the other ones, is I would move that to the other side. So I would get 3x squared plus 8x equals negative 21. I'm going to get rid of that lead coefficient, so I'm going to divide by 3. So I get x squared plus 8/3 x equals negative 7. What do you add in? Well, let's see, 8/3 divided by 2 is 8/6. Square it would be 64/36. So I have to add 64/36 over there. So if I factor, I get x plus 8/6, x plus 8/6. Now for those of us who kind of struggle with this whole factoring part here, especially when there's fractions involved, a pattern that you'll notice is that this right here is always the square root of this right there. Okay, every single time. If that's a perfect square trinomial, that will be true. Okay, so just kind of be aware of that. That might help you out a little bit. All right, so if I combine over here, let's see, I get negative 188 over 36, I believe. Let me do that again on my calculator real quick. Yeah, negative 188 over 36. Now I know that can reduce, but let's just leave it for now. So let's rewrite this over here. So x plus 8/6 squared equals negative 188 over 36. That's square root. Okay, so I get x plus 8/6 equals plus or minus the square root of negative 188 over 6. Now, a couple things you might be saying right now. One of them being, well, how can you have a negative in there? Well, that's fine. That's just going to be an imaginary value or a complex value. And then we also need to do some reducing. So let me bring this over to the other side over here, and let's clean this up a little bit. So you get negative 8/6, which I know that can be reduced, plus or minus now 188. Let's see, how can that break down? Let's see, I believe 4 will go into it. So it'd actually be 2I root 47 all over 6. And so I can do some cleaning up here. So if I rearrange, I'm going to get plus or minus root 47 over 3I minus 4/3. Actually, I don't even know why I wrote it like that. Let me flip that around, because we want to be in A plus BI form. So negative 4/3 plus or minus root 47/3 over I, or not over I. And there you go. So again, not a great looking or clean, I guess, answer to it, but not an awful thing to kind of find. You know, something that you might want to ask yourself, well, what the heck does that mean? Why is it an imaginary value? Well, this is a situation where, you know, if you were to be graphing this parabola, I don't know what it looks like off the top of my head, but this would be something where you wouldn't have any x-intercepts. Okay, it doesn't cross the x-axis down here, and whenever that occurs on a parabola, that means you have imaginary values, or complex values, I should say. And remember, you should keep your answers whenever you have complex values in A plus BI form. Okay, so that's it. That's how you go about solving things in with completing the square. Completing the square is an incredibly useful and incredibly helpful method for solving. It's something that we're going to use quite a bit.